You know, when we search for life out there in the universe, we're pretty much looking for a mirror image of ourselves. But what if that whole approach is, well, just wrong? What if the story of life isn't a single book, but a library of completely different stories?
Okay, so to get our heads around this, let's start with a really cool thought experiment from the paleontologist Stephen Jay Gould. Back in 1989, he asked this question: what if you could literally rewind the tape of life's history, all the way back to the beginning, and then hit play again? Would it all turn out the same? Gould's answer was a definite no. He believed it would unfold differently every single time. And that one idea, it's the key to completely rethinking our search for aliens.
Gould's whole replaying the tape idea isn't just a fun little puzzle to think about. It really forces us to confront a huge scientific question. Is life on Earth the inevitable result of chemistry and physics? Or are we just a beautiful one in a trillion accident?
And believe me, this isn't just a philosophical rabbit hole. This question gets right to the heart of a massive scientific debate that really shapes how we think about life, not just here, but anywhere in the universe.
This huge debate pretty much boils down to two competing ideas. On one side, you have contingency, and on the other, you have convergence. These are basically the two rival theories for how evolution really works.
So first up is contingency. And this image, it shows it perfectly. Think of life's history as a road with a million different forks. A totally random event, like a giant asteroid slamming into the planet, could send life careening down a path it would have never taken otherwise. From this point of view, we are here purely because of a very specific and unrepeatable series of lucky breaks. And then you've got the other side of the coin, convergence. This picture shows the exact opposite idea, that no matter which path you start on, you'll eventually end up at the same destination. The idea here is that physics and the environment create such strong pressures that evolution will find the best solutions over and over again, independently. It's why wings evolved separately in birds, bats, and insects. Flying is just a really, really good idea.
So, let's just break it down. Is life an unpredictable accident, a total roll of the dice? That's contingency. Or is it a predictable outcome, a target that evolution is always aiming for? That's convergence. The answer to that question changes everything about what we should expect alien life to look like. Okay, so this is where it gets really interesting. Let's take this huge debate, contingency versus convergence, and apply it not just to dinosaurs or mammals, but to the biggest question of them all, the very origin of life itself.
And this is where we run into the single biggest hurdle in our search for alien life. It's called the n=1 problem. And it sounds technical, but it's actually super simple. It just means we only have one example of life in the entire universe to study: life on Earth. That's it. Our entire understanding is based on a sample size of 1.
Because of this n=1 problem, we've kind of fallen into this trap. We just assume that the recipe for life started with a nice clean pantry full of ingredients. The 20 amino acids we use, the right kinds of nucleic acids, all just sitting there ready to go.
But the thing is, the evidence points to something completely different. Early Earth wasn't some neat and tidy lab. It was a mess. A chaotic, complex, messy chemical soup with all sorts of stuff in it.
And I mean, just look at how messy we're talking about. In that primordial soup, the building blocks that our life is based on, they were a tiny, tiny fraction of what was actually there. Think about this. The famous Murchison meteorite, which is like a chemical time capsule from the early solar system, contained tens of thousands of unique organic compounds. The familiar amino acids we rely on were just a drop in the bucket. So what does that mean? It means there was this giant menu of alternative building blocks just sitting there. And if they were way more common, couldn't they have kicked off their own version of life? Couldn't there have been totally different recipes cooking in that soup?
So what are these non-biomolecules anyway? Well, they're pretty simple, really. They're just all the other organic molecules that were around on early Earth, but, for whatever reason, didn't make the cut for our brand of biology. They were the chemical roads not taken.
And these other molecules could do some amazing things on their own. Here's a great example. Simple things called hydroxy acids, which were probably everywhere, can easily link together to form polyesters. And get this, in water, those polyesters can spontaneously clump together into these tiny droplets that look and act a lot like primitive cells. It's a completely plausible alternative way to build one of the most basic structures of life.
So when you realize that life could have started from this messy chemistry, using totally different ingredients, well, it completely redraws the map for astrobiology. It suggests we've been searching for a very specific type of needle in a haystack full of needles.
So what does this new map actually look like, compared to the old one we've been using?
First, here's the old map. This is basically the deterministic view we've been working with for decades. It's this clean, straight highway from simple chemistry to life as we know it, using only the parts we're familiar with. It's predictable, it's tidy, and it's been our blueprint. But this is the new map, the contingency model. It shows that starting from that messy chemical soup, there are countless possible roads. Yeah, a lot of them are probably dead ends, but while one path might lead to our kind of life, another could fork off and lead to something completely different, life as we don't know it, built on an entirely alien chemistry.
And this brings us to a really profound conclusion. If we want to find that kind of life, we have to change how we look. We can't just scan for DNA or specific amino acids. We need to start searching for what are called agnostic biosignatures, signs of complexity or weird chemical imbalances that just scream life without being tied to our specific recipe.
Which leaves us with one last, really big question to chew on. In this incredible quest to find out if we're alone, have we been looking for the right clues? Or has our own reflection been blinding us to a cosmos that could be teeming with possibilities we haven't even begun to imagine?